Hi guys, Francisco Joe here. I'm here to talk about our project. First things first, I want to talk about the process model that we chose. We initially chose the waterfall model because that was the first one we learned about and that we just spent like the first few weeks doing documentation either way. Uh, but then we moved on to the incremental approach once we started coding more. Next thing I want to talk about is our functional requirements. I won't be able to get through all of them, but I'll get through some of the main points. First things first, the user database. The user database holds information of the user, such as username, email, password, data registration, description, all that fun jazz. Next, I want to talk about the auction database. This held all information about the auctions, such as users that were selling, the images that were attached to the auction, the pricing with the auction, and the time frame for when it would expire and for when it was created. Next, I want to talk about the login system. The login system basically determined what the user had access to depending on whether they were logged in or logged out. It also like changed the format of the page depending on that. Next is register system that would register users into the user database once they registered. Next, I want to talk about our search bar. This basically allowed users to search for certain items through the home page. They also were able to use tags and order the sort. Next, I want to talk about our non-functional requirements. We had a password policy that was in place to keep things more secure. This included requiring a lowercase, an uppercase, a special character, and a number, and also requiring it to be 8 characters long. Next was web page standardizing. This was just us making sure the web pages looked familiar. You'll be seeing that soon in the wireframes. Input sanitization is something we didn't get to implement, but we hope to do that in 152. Next is user experience, which is just basically CSS and making things look fancy. Next is the wireframes. As you can see, we have 2 for homepage, one for when they're not logged in and one for when they are logged in. You can see we have a logout page and a create auction page that is now enabled. Next, I want to talk about the login page. As you can see, it's just kind of plain. We haven't included forgot password and register in case they haven't registered with us yet. They can register from there. Next, I want to talk about the actual register. You can see we included an email, username, password, just register. Let's see. And then next would be the auction page for the buyer. This is when the buyer goes and checks and they're enabled to enter a bid. And this is the auction page for the seller. This is to allow them to edit the page so they won't be able to bid on their own auction. Insert image. This would be the actual edit once they edited the auction, so they could change the information on there. This is to create the auction from the very beginning. Profile page, edit profile page, be able to submit. And then our help page, which basically just boxes of information. And then a forgot password page, and logout page. That's it for me.
Next, I'll present the diagrams that we created for this project. The first one is the use case diagram, which shows all the different interactions within the application. The main actors using the program are the 2 databases as well as the users, which can be registered or non-registered. The non-registered user can only view pages, which subsequently allows them to be able to use the filter and search functionalities. They also interact with the register functionality. Registered users have the access to all the other functionalities like the ability to log in, edit their profile, edit an auction listing. For the 2 databases, we have the user database and the auction database. The user database interacts with all of the functionality pertaining to the user, and the auction database handles all the functionality pertaining to the auction. The next diagram is the class diagram. The class diagram, we have the user database, which is a collection of the user objects. There can be an infinite number of users in the database, but as few as 0 is allowed. Originally, we had subclasses of user, which were the seller class and the buyer class, but we changed it because this diagram better represented what relationships we had within our code. The auction database is similar to the user database. It is a collection of auction objects. There can also be an infinite amount of auctions and as few as 0 in the database. Finally, there is a relationship between the auction class and the user class. Users have the ability to create auctions, so there can be auction objects within the user class. The range of auction objects that can be in the user class is 0 to infinity because users don't have to have auctions, but they can have as many as they want. Similarly, there can be user objects within an auction. There has to be one which represents the seller because there can only be one seller per auction, but an auction has to have seller. There can be as many bidders, so that creates the infinity part of how many user objects can be in the auction class. Next, we have the sequence diagrams. We have 2 sequence diagrams, one for posting a listing and one for signing up. For this one, you basically, if you click a link, then it will return to you the create auction page, and you can create an auction, and there's a submit button which you click, which creates an auction object, which is then returned back to the user along with the auction page that displays that new object. For the next sequence diagram, it's for signing in. Pretty similar. You just click a link and it will return to you the sign up page. You click submit after you put all the information in, which creates the new user object for the database and returns that object with the profile page for that object. And that is it for the diagrams. I'll hand it over to Brian now.
Everybody, I'm Brian. I'm going to go over our project board and then some of our implementation design. For our project board, we used it pretty intuitively. We just threw all of our requirements into this product backlog, and then along with live activities and other miscellaneous things we did. And for every weekly iteration, we would just select activities from the backlog, put them in the to-do list for the week, and then as we finish our activities, we throw them in the done column. And then we also have this column over here, and that's just to add some things we could do if we were to continue this project into CSCI 152. And as far as implementation goes, the tools we used was Git Bash and GitHub, and then Visual Studio Code was used primarily for our source code editor. The stack we used, it's known as MERN stack. It consists of MongoDB, Express, React, and Node. So MongoDB is just the database that we're using. Express is a server-side framework that runs inside a Node server. It's great for URL routing and then also for HTTP request handling. And then together, Express and Node, they bridge the connectivity between React and MongoDB. And React, it's a JavaScript framework for client-side applications. For our work distribution, Daniel was our full stack developer, and he worked exclusively on our backend. He also helped out on the front end with the create auction page. Everybody else on our team, we were exclusively front end developers. Here were all the pages that we primarily worked on, along with related functions for those pages. So pretty much what everybody did was we have a page or pages we were in charge of, and then because of that, we were also in charge of related functions for those pages. And then there are a few other things that each team member did in addition to just those pages and functions. So let me show you guys a little bit of our source code. So our code organization is as follows. We have our client folder and our server folder. In our server folder, it consists of our models, which are our schemas. They all define the different attributes for each schema. For example, here's our auction schema, and it consists of different attributes like their name, description, the data was posted, URLs for the images, and the author. And then you can see similar things over for the user model. And you can actually see that translate over to MongoDB right over here. For example, we have a list in the database of all the different auctions we have currently stored and all the different attributes for each auction. Same deal with the users, the list of all the different users and their attributes. Our controllers folder in the server folder, they define all of the different HTTP requests we can do from the front side over to the database. And they all define things such as getting an auction from the database, deleting, creating, or updating it. Similar with a user, you can get a user, update them, delete them, check if they're valid and whatnot. On the client side, we have it divided up into components and pages. Components are just some things that we have that are utilized in different pages or multiple pages, such as our countdown timer. Our pages hold all the logic and functionality embedded for each different page. For example, the auction page for the buyer holds functionality for redirecting to different pages based on who is logged in or what they're trying to do, such as placing bids. And all of these different pages are compiled into this app.js file where each page is defined by a URL pretty much. So every time a user were to click on a link using our navlink library and whatnot, it would render that specific page's information. Now I'm gonna pass on to Gerline, who's going to talk about our issues we encountered.
So these are some of the issues that we faced during our development process. We all put our issues inside GitHub and we closed them as we figured out the solution. One of the problems what we had was when I was working on the edit profile page, updating the profile picture was a little tricky. One of the main issue was that I was running into race condition. So if the profile picture was taking a long time to upload and other areas were done updating, for example, username, it would just keep updating the picture and finish the function. I wanted to put a weight on the update profile picture, but it wouldn't let me because it was a variable. So I had to reorganize my code in a way so that if a profile picture needs to be updated, it waits for the profile picture and then it finishes the function. Another issue we were having was getting the auction product cards in a grid view. They kept overlapping on each other or the home page. So trying to get all the images to fit inside the card and making them all the same size was hard. We also ran into some issues when we were trying to implement the auction page because the view of the auction page depended on whether the user is a seller or buyer for that product. Most of our issues had something to do with the controllers preventing us from implementing some functionalities. So when Daniel would edit the server side things, the issues were resolved. And as you can see here, we still have some of the issues that are still open. We didn't have enough time to find a solution to them. For example, input sanitization, we didn't have enough time to implement cybersecurity requirements. But if we do continue to work on this project next semester, these are a few things that we would like to get done. And I'm gonna hand it over to Daniel to show you the architecture model for our project.
So to wrap up this presentation, I'm gonna go over the architectures that we used. So first we used a MVC architecture where the models were the models for the database schema that we used in the backend. The view was the UI or the website that we used on the front end. And the controllers was the routes and controllers that I developed in the backend. And of course, we also used a client-server architecture to communicate between the website and the server. And then finally, the database was also a repository architecture. And that's it for our presentation. Thank you for watching.